Good morning, ladies and gentlemen. It's quite an honor and a pleasure for me to speak at the Dongbo High-Tech's annual Semiconductor, Analog Semiconductor Leaders Forum. And before I start, I would like to briefly introduce myself and set the stage. I grew up in Taiwan, and after receiving my BSEE degree from National Taiwan University, I went to the University of Illinois, Urbana, for my graduate studies. My research and PhD thesis were in the area of logic synthesis. In today's terminology is the ADA. Unfortunately, after I graduated, there was no EDA industry at that time in the United States. And the only companies that were doing logic synthesis research, or EDA, were companies like IBM and Bell Lab. And unfortunately, I didn't have the permanent residence, therefore I could not even interview with them. Therefore, I went to a small place in California called Silicon Valley. I call it a small place because it was still in its early days in the Silicon Valley, and went into the design sector of the industry. So I stayed in the Silicon Valley for 25 years and worked in 3 application areas as a designer, design manager, and so on and so forth. And those areas were CPU, graphics, and GPS. So by the end of 2002, I went back to Taiwan and joined the UMC. And as you know, UMC is a foundry company. So I had like 5.5 years of experience in the semiconductor foundry. So I left UMC in July last year and recently joined a startup company called Neo Energy Microelectronics, which is a fabless analog and mixed signal IC design company focusing on energy efficient applications. So today my topic is semiconductor trends in Taiwan and China. I think it is proper for me to talk about this topic due to my presence in Taiwan and China in the last few years. In order to understand the trends in Taiwan and China, I have to share with you the trend in our industry, in the entire semiconductor industry first. And the first opening remark that I would like to provide is that our industry has been facing unprecedented challenges and changes. And those challenges and changes, of course, will introduce many new opportunities. And the opportunities will be there for those companies and the individuals to grab if they are capable and ready. The following trends were observed by myself and many executives in the industry over the last several years. Trend number 1. As Moore's law continues to evolve, the wafer demand for certain applications may be decreasing instead of increasing. I started to notice this even several years ago. I think every company in the semiconductor industry works on its business plan or budget around September, October timeframe. And the first thing you do is to collect the demand forecast from your customers. And if the demand forecast in terms of wafer is decreasing suddenly, you would be alarmed and you would immediately ask a couple of questions. Number one, is the customer's market share reducing? Number two, is the customers given the wafer demand to your competitors? And if the answers for both questions are no, then you will be really worried. And one of the reasons is because of the Moore's law. I think everyone in this audience is familiar with Moore's law, which states that if the gate count or complexity of a design stays the same when you migrate to the next generation of process technologies, your chip size will reduce by 50%. Or the number of dies may double for the same number of wafers, right? That's the Moore's law. So what factors will help drive the wafer demand, to continue to grow? Number one is, of course, the annual growth rate of the applications, right? So if the annual growth rate is at 40% every year, so after 2 years, then you got 1.4 times 1.4, that's pretty much 2. So that means even if the complexity of your design stays the same, the wafer demand will be the same when you migrate to the next generation, right? Or if the complexity of your design increase significantly, you put in more and more functions, your die size increase, that will help drive the demand, wafer demand also. Unfortunately, or fortunately, depending on how you look at it, the process technology continues to migrate according to the Moore's law, and the industry tried to put in more and more functions, and suddenly for many functions, they reach the so-called the diminished rate of return, and therefore they don't need that many wafers. So this leads to the second trend. Oops, it's already there. So many companies started to worry that what applications can make use of the most advanced process technology. And this concern started even several years back. And this is a true concern. And you can probably number them, within 5 fingers. CPU, the GPU, the graphics processor, and the FPGA are 3 applications that can probably continue to take advantage of the most advanced process technologies. And the high-end consumer product, such as digital TV and cell phone, they may not even need such high density when the process technologies migrates to 22 nanometers. So for foundry companies that are investing significantly to offer the next generation of process technology, that is a major concern. The third trend that becomes obvious is the investment for advanced process technology becomes more and more expensive. And therefore, most of the IDMs have adopted so-called fab-lite strategy. The industry are quoting that it took $300 to $400 million for the development of 90 nanometer and 65 nanometer technologies, or between 500 and to 600 million for 45 nanometer, or more than $1 billion for 32 nanometer process technologies. But I believe the investment is higher or much higher than what people think. Because besides the process technology development, you need significant investment in IP for the next generation of technology so that your customers would come to you. And in terms of manufacturing capacity, people used to say it takes about $100 million of investment for 1,000 pieces of 12-inch capacity for 90 nanometer manufacturing. And that number may have increased to $140 million per 1,000 pieces of 12-inch wafer per month at 45 nanometer. So you can see the investment is becoming higher and higher. Therefore, back in last 3 or 4 years, you have already noticed many companies, so-called IDM companies, have adopted fab-lite strategy. In the United States, you have Freescale, you have TI, those leading IDMs. They decided not to invest in advanced process technology anymore. In Europe, Infineon, ST Micro, and in Japan, Sony, Fujitsu, and so on and so forth. So that is a global trend. Trend number 4. People also notice that the process technology development seemed to have slowed down due to the uncertainties that involve new materials. And many of you may have remembered in our industry when it migrated from aluminum for interconnect to copper, right? That is from the 0.18 micron generation to 0.13 micron generation. That was a pain for the whole industry because copper was a new material, and it took a long time for the industry to master the robustness of copper interconnect. And now we are facing the same situation, and you probably have noticed that new material, so-called high-K and metal gate, will be needed for 45 nanometer to start with, and definitely needed for 32 nanometer. And that's why there seems to be some degree of difficulties for foundries be ready for 45 nanometer production. And that degree of difficulty may become higher as you move into 22 nanometer, which is the next node after the 32 or 28 nanometer. And one difficult area is the lithography. People are talking about EUV, the extreme ultraviolet technology, and now what we heard is that technology won't be ready for production until year 2012. So the whole industry has high hope and also expected to have some good luck so that the technology can continue to migrate. So starting from 1965, when Mr. Gordon Moore introduced the concept of Moore's law, our whole semiconductor industry pretty much followed that prediction, and the entire food chain or supply chain, followed the Moore's law. And in our industry, if you don't follow the Moore's law, you will be perceived as behind the leader. And therefore, from the process technology to the design and to the EDA industry, the equipment supplier, and the materials, everybody along this food chain follow the Moore's law. And is the Moore's law going to continue forever? I remember when I was a senior engineer, it was probably back 20 years ago, the industry was forecasting that 0.1 micron or 100 nanometer would be the physical limit for our industry. And fortunately, today we have already broken that barrier. We are now into 45 nanometer production. Can we continue? In 2007, in Intel's investment forum, Mr. Gordon Moore, he himself made the following statement, saying that Moore's law will hit a wall in 10 years. So that is, if we predict, right, today at a 45 nanometer and 2 years go down to 32 nanometer, and 2 years go down to 20 nanometers, and 2 years after that go down to 15 nanometer, and then after that, would the technology be ready for every 2 years, right? And people start to count how many atoms would be at the gate oxide, right, as the technology continues to scale down. Right. This is stated by Mr. Gordon Moore. And I also noticed recently, Intel made another presentation about his process technology roadmap, and they predicted by year 2022, the geometry will be down to 4 nanometer. 4 nanometer means equals 40 atoms. You can count the number of atoms at that time. And they said they will need some luck to break the barrier of 8 nanometer, several years in between, right? So this will be a very, very interesting development situation to watch for. The next trend is related to IC design companies. As I mentioned earlier, in the past, that everybody jump onto this Moore's law wagon every 2 years, including the design companies. But suddenly, about 2 years ago, I noticed that many companies, they cannot do that anymore. They start to skip nodes. For example, after 90 nanometer, they decided not to go to 65. They will wait and for 45. Or after 0.13 micron, they decided to skip 90 and jump to 65 nanometer. And what are the reasons? There are a couple of 2 main reasons, or maybe 3. Number 1 is because of the increasing product complexity, that they have to add more and more functions in their chips and spend much more time in simulating their design and make sure it's ready. And the number 2, as they are adding more functions, they need to prepare many more IPs. Some of the IPs were from their previous designs. Some of the IPs are new. And the IP migration from the previous technology to the new one and the preparation for the new IPs both take tremendous amount of time. And the third reason is actually the high mask cost. High mask cost, right? And if you are the early adopter of an advanced process technology, you pay a tremendous amount of money for your masks, right? And it could be millions of dollars at the beginning, all right? Therefore, unless your volume is so huge, right, the number of wafers is so large, then you can justify. Otherwise, they probably want to wait. Trend number 7. Therefore, for the design companies, they must become more innovative. In the past, following Moore's law was a major winning factor for them. And then nowadays, it's not necessarily the case. I used to be in the graphics business. Graphics is one application that must embrace the most advanced process technology the earliest. And the reason is because with the advanced process technology, you can add much more complexity. You can add many more pipeline to improve the performance of your graphics processor. Therefore, the die size of your next generation graphics processor can stay the same as your previous generation instead of reducing to 50%. Then consider their market growth. So their demand, wafer demand, continue to grow. That's how the graphics processor industry compete. They still compete the same way. However, for many other applications, such as cell phone or consumer electronics, they have to compete in different way now, in my opinion. And companies who are creative in architecture and who are doing better in execution will eventually be the winner. And fortunately, in the area of analog design, there still exists plenty of areas for innovation. So analog industry or analog application is one area that does not migrate very quickly in terms of advanced process technology. They tend to add more values. And the next trend is in terms of manufacturing capacity. I was a customer. I was in the design side in the middle of the 1990s. And if you still recall, during those years, there was a severe shortage of wafer capacity. And I was the senior VP at S3 at that time, and I was given the mission to go to area, try to secure enough capacity. Therefore, we did a deal with UMC, formed a joint venture fab. We did a deal with TSMC for a prepayment program to try to secure capacity. But after that, many new foundry companies entered the industry. And IDMs also at that time, there's still IDM. And everybody started to invest like crazy. So several years back, or 10 years from that, now everybody noticed there was too much capacity in the world, both in terms of matured process technology and advanced process technology. And this recent economic meltdown make it very, very bad, make it worse. And in a few slides, you can see the impact. I read a report recently that Dongbu has improving utilization, or you are already talking about the full utilization. Congratulations, you seem to have recovered sooner than the rest of the industry. But overall speaking, I think overcapacity is still a concern. Of course, during this market meltdown, And many companies have constrained their investment in the advanced process technology capacity and also have shut down many fabs, for the non-competitive technology capacity. So that would help the industry for a while until people start to invest heavily, and then the situation may happen again. In the next several slides, I'm going to take you through certain product ideas, including memory, logic, and analog, and in different geographic areas also. First of all, let's look at DRAM. DRAM is a huge market, as indicated here. By 2007, worldwide DRAM market was 31 billion, and 2008 reduced to 24 billion. And in the DRAM arena, Korean companies, namely Samsung and Hynix, are the clear leader. These two companies totally had 49% of the market share, and followed by Elpida, Micron, Qimonda, and so on and so forth. Qimonda actually was number 3 in 2007. And as everybody knows, it has already filed for bankruptcy this year. And Taiwan has 4 small DRAM companies. Totally, the combined market share was around 11-12%. And also they have been facing tremendous pressure during this recession. So later during the question and answer area, I have one question for the audience that I would like to learn from you. Why Korea is doing so well in memory products? What are the magics? And I can learn that from you. And talking about memory, flash memory, NAND NOR is another huge area. And again, Samsung is a clear leader with 30% of market share, followed by Toshiba. And a company called Spansion was number 3 in 2008. It also went bankruptcy and trying to come out of Chapter 11. And followed by Mnemonics and Sandix and so on and so forth. And Taiwan is very, very small in the area of flash memory. So Korea companies dominated both DRAMs and the flash memories. Next, let's talk about foundry for logic products. Here is a summary of the top 4 foundry companies for 2007 and 2008. And it showed the market share and the ranking. And TSMC clearly was the leading company. And during difficult time, it seemed to have performed even better. And Charter Semiconductor seemed to have come back a little in terms of market share for 2008. And one thing you have noticed that 2008 was a difficult year, and a couple of players like UMC and SMIC, their revenue have reduced. Then by the end of 2008, we have this market meltdown started, and Q1 was the worst for the whole industry. And one thing I'd like to point out is the utilization. I was talking about the overcapacity situation, and that situation became very, very clear during the market meltdown. And so companies such as UMC, SMIC, or even Charter, their utilization was below 40%. And even TSMC, the number 1 company, had only 40%. And TSMC was the only company that could make a profit during this difficult time. And the situation changed, improved quite fast, actually, in Q2. And TSMC's utilization returned to 85%, and also the profit level has increased significantly. One thing I would like to point out, only two companies were able to make profit in Q2, TSMC and UMC. But if you count the level of profitability, TSMC took 95% of the overall profit for the entire foundry industry. So in the US, there's a saying that there's only one number one in every industry. And this is clearly the case. The next sector I would like to talk about is the fabless industry. Here listed are the top 10 fabless IC design company and their revenue and market share for 2007 and 2008. Qualcomm is a clear leader and maybe doing better in the fabless arena, followed by Broadcom and Marvell and NVIDIA. One thing worthwhile to point out is there's a Taiwanese company called MediaTek that has become number 5 during the last 2 years. And they seem to have made good penetration in DVD, DTV, and especially cell phone baseband chips. And there are 2 more Taiwanese companies that entered the top 10 list. They are ranked number 9 and the number 10. And one's called Himax, another one Novatech. Both are providers of LCD drivers. Okay. And 2 US companies dropped off the list in 2008. They were SanDisk and Avago. So clearly, 2008 was a tough year for many companies. The next list showed the top 10 fabless design companies in Taiwan in terms of revenue. And MediaTek is clearly the leader, and Himax is a distant number 2. And one analog design company, Richtech, has entered the top 10 list. And so Taiwan has become more and more significant in fabless industry. If I remember correctly, totally their revenue is around 18 to 19% of the entire fabless industry in the world. And the US fabless companies accounted for 75% of the revenue, pretty much in that category. And in my prediction, the Taiwan Semiconductor company will continue to grow in fabless area for the reasons I will talk about later. The next slide shows the revenue ranking for the fabless company in China. As this list shows, that China fabless companies had faced tremendous pressure in the last year. Many of them shrunk significantly in terms of revenue, except one company called HiSilicon, which is a subsidiary of Huawei. So I think it's because their internal business shifting or merger situation, their revenue showed a tremendous growth. But all other companies are facing a difficult time, right? As a matter of fact, in 2006, the top company, it's not proper for me to mention the name, actually fell off the list for 2007 and 2008, right? And some company used to be number 1 at the top, now are ranked number 7, number 8, number 5. So I will talk about the reasons in the next slides. So in order to understand the semiconductor industry in Taiwan and China, I did the following SWOT analysis. In China, even back 10 years ago, the government wanted to develop the semiconductor industry or the high-tech industry, and therefore it provided all kinds of incentives for the local industry. And it has tremendous support from capital, land, and all kinds of other incentives. And to me, the most attractive strength for China is the talent pool. China, like Taiwan, started to have Silicon Valley expatriates, and which contributed significantly to China's semiconductor industry growth. And also, every year, the universities produce a large number of talented engineering students. In my opinion, they are not worse and probably better than the students graduated from Taiwan. But the numbers way outnumbered the Taiwan. And you probably are aware, many US universities, many US companies have established design centers or have joined programs with universities. Universities in China will play a very important role. So don't believe you have not established good R&D development programs with Chinese universities you may want to consider. And in terms of weakness, I think the foundation of any industry, it takes time. I think basically that's the weakness of China. It takes time. As far as I can see, in the design capabilities such as SOC, and in terms of yield for foundry manufacturing, and process technology development, and so on and so forth, and especially managerial skills, China still has a long way to go. But with the talented engineers and the engineering workforce, I believe they will have an opportunity. And therefore, you need to watch China very, very closely in terms of competition. But definitely, China is a great opportunity in terms of a market, available market, and you need to watch for it. In terms of opportunities, China is one company that has, I see, in terms of opportunities, China is one company that has, I see, has a huge opportunities in its market, of course. And also, it has the capabilities to set standards. And everybody is aware of the 3G standard in China, called the TDS CDMA, right? The Chinese government can hold the release of 3G license for so long and nurture the development of its own internal technology. Not many countries can do that, right? And it has a huge market, and it has the capabilities now to develop its own, to set its own standards. That is powerful. And also, I can perceive that the number of fabless companies in China will continue to grow. Recently, I heard it's the Chinese government's will to develop 30 additional fabless companies, which will have $200 million of revenue in a few years. Okay, so the government, Chinese government, still has a strong influence to its industry, and it will provide the capital and the policies to help. And in terms of threats, China definitely is one area that has not put enough emphasis in its IP and IPR, IP rights, right? That's one area that you need to watch for. And China will face more and more global competition. In order to become a global player, it has to play the global rules. Last year, in last May, I gave a presentation in the GSA, this Global Semiconductor Association Annual Forum in Shanghai. That was before the Olympic Games. So I mentioned to them, China is going to hold the Olympic Games. And in the Olympic game, everybody plays the same Olympic rules. Therefore, one day, China, in order to play the global game, it has to play the global rules. Right? And also, China will have to face the issue of return on investment. In the last 10 years, 15 years, it's in a nurture mode, nurturing the industry, either from the government or from the private sectors. And that return, that investment must have a return. Otherwise, no matter whether it's the government or private sector, they are not going to continue to invest. I think the China semiconductor industry start to realize that, especially for foundry capacity, they are not investing like what they used to, right? They used to think there's plenty of demand, and both globally and also in China. Therefore, once we invest, then we will be able to attract customers, fill the fab, and have good return. And after a few years, they realize building the fab is the easy part. Filling the fab is much harder. And therefore, from the government, from top government, they are not encouraging the local government to invest in fab capacity anymore. On the contrary, they are encouraging fabless design companies, which I think is the right trend. Okay, let's do the SWOT analysis for Taiwan also. And the Taiwan industry started in early 1980s. For your information, the Taiwanese government had a policy of sending students to the US for studying high-tech many, many years, even before 1980. Well, I was one of the students that graduated from Taiwan, went to the US for graduate studies, and stayed there in the US industry for many, many years, and eventually went back to Taiwan. So because of that policy, it nurtured and developed many, many engineers in the semiconductor industry. And when Taiwan started to develop its own semiconductor, and many of those people returned. And so over the last 29 or almost 30 years now, and it has developed the skillful engineers and also very seasoned managers. And those form the core of the Taiwan's semiconductor industry. Taiwan still have a reasonable labor cost. For hiring each senior engineer in the Silicon Valley, you can hire 3 engineers in Taiwan. And of course, weakness, there are still quite a few, in my opinion. Still, many, many companies, including design companies, are focusing on Me Too products, right? And one thing interesting is there are not many good marketers in Taiwan because of the ODM mindset. When they start up companies, they attract engineers, good engineers, because the product they are doing is me too. They don't need good marketers. That's one thing I find out very, very interesting. And Taiwan is still far behind in analog and mixed signal designs compared with the world leaders. Finally, one thing that worried me most is the fundamental research in materials in Taiwan. This is one area Taiwan is weak. And recently, I was encouraged by an announcement, which you may have noticed. ITRI, which is the Taiwan government-owned research organization, has won an award, an innovation award, for its paper-based speaker. It was in the news in the last 2 days. So hopefully, it will continue to make improvements in this area. Opportunities. Weaknesses are also opportunities. As I mentioned, there's still huge room for catching up in analog and mixed signal design. Taiwan has one advantage, that is to survive well, to have a good stock price in the market, in the Taiwan, in local market. You don't need very high gross margin like the US companies. US analog companies, they all pretty much have 50, 60, or even 70% of gross margin. But in Taiwan, if you have 40%, 45%, you can survive well. So because of that advantage, they will continue to make inroads and progress in technology and the product development. And also because of their accumulated experience in manufacturing, they are well positioned in pursuing the green energy opportunities. Finally, let me talk about the threats. There's a saying that in China and also in Taiwan, that people prefer to be the head of a chicken rather than the tail of a bull. And what that means is they prefer to be the head of a small or medium-sized company rather than be a contributor, individual contributor of a large conglomerate. This is a clear difference between Korea and Taiwan and China. In Korea, you have very few conglomerates, very large companies, right? Like a Samsung, Hynix, and so on and so forth. But in Taiwan, right, you have many, many small and medium-sized companies. And as a result, merger is very difficult in Taiwan, right? In my own opinion, during this market meltdown, the Taiwanese DRAM companies should have merged, and it did not happen. Okay, now the DRAM price start to return. Everybody feel relieved. They may be happy for a while, but to me, that's not normal. That's not healthy, because it will go down again, and they will face tremendous pressures again. But this is a cultural-related thing. It's very difficult to change. And over time, the Chinese fabless, once they have learned how to design, once they have accumulated the skills, they may be a threat to the Taiwanese companies. Okay. Taiwan opportunities. I think Taiwan, this terminology is probably invented by Korean companies, and they perceive the combination of Taiwan and China be a threat to Korean and also other areas. And indeed, if these two areas fully utilize the synergy or some of their strengths, they can be an important factor for the semiconductor industry. As far as I see, China has large system companies such as Huawei, Datang, Zhongxin, that Taiwan does not have. This is one area Taiwan is very weak. You know, Korea is also strong in this area. You have SK Telecom and you have large companies. China also has more experts in RF and analog design, especially at the system level. Due to what reason? Due to military needs. So they have such talents. China has a large pool of well-educated engineers we talked about. And Taiwan has skillful designers and managers. And if they can combine the synergy, they can create, you know, a lot of opportunities. As a matter of fact, many Taiwanese design companies have established a design center in China to provide a local support and also to develop customer needs for the local customers. And one thing that is helping is the improving political atmosphere between Taiwan and China. After Taiwan has a newly elected president. However, in my opinion, there's still too much capacity, and the foundries in Taiwan and China, they should consolidate. And currently, there's still some government policy that prevented that from happening. But I think over time, it should happen. The last presentation shows the top 10 semiconductor suppliers over the last 4 years. And they listed the leading players every 10 years. And you can take a quick look. It's very, very interesting. In the 1970s, there's a small company called Intel. They just show up on the list. And in 2008, Intel, well, even in 1998, Intel has become number 1. And 2008, Samsung is number 2. So there's one question. Who will rule in 2018? Which will be the top companies in 2018? The prediction is Intel and Samsung in terms of revenue. However, there are 4 companies that are performing very well and are very rich, will do very well. Those 4 companies are Intel, Qualcomm, TSMC, and TI. By the way, TSMC is not on the list. Probably it's categorized as a foundry company, but I think they should, right? And in terms of revenue, you know, TSMC is probably at the middle of the list, and will do quite well. So those companies have plenty of cash, tons of cash, and they can use that cash to fund their continued research and continue development to stay as the leader. Okay, finally, here is a question list. And there are 3 questions that I generated, and definitely you're welcome to ask questions after that. First question is, what will happen if Moore's law is real? I mean, if Moore's law hit a wall in 10 years, what will be the implications to our industry? Anyone in the audience would like to answer? Mark, did you raise your hand? Okay, I'll give you my quick answer. I think if this is the case, it will give tremendous pressure to every player along the supply chain, right? For example, for the foundry, if the process technology migrating into the next generation slows down, then the followers will catch up the leaders, right? So everybody will have the same yield for that node of process technology. Therefore, it will, it will offer to all the customers, and therefore there will be tremendous price pressure to the leaders. And also, to the design companies, they have to think much harder, to innovate much harder in order to differentiate themselves. And to the EDA companies, to the equipment vendors, they will all feel tremendous pressure. So let's pray it is not the case that Mr. Moore is wrong and the technology will continue to evolve like 20 years ago. Second question, why can Korean companies lead in memory products but not in logic ICs or foundries? I was a customer of Lucky Ghost when I was in S3. Lucky Ghost provide ASIC chips to S3, and the business did quite well. I was a customer of Samsung when I was at SURF doing GPS. Samsung provided GPS controller to SURF, and that was also a successful experience. I don't know the answer. Someone must help me in the audience, please. Mr. Park, maybe you can help me.
I'm not sure, but Korean company likes some, rather than a chicken head, bull's head, so they want to have a short time big investment, short time big returns. So large companies prefer that kind of thing.
Okay, that's probably the reason. Yeah, I think it's a good reason because for DRAM, to compete in DRAM in memory product, you need very significant investment, right, in capital equipment and in manufacturing capacity. And that's one area that Korean companies definitely did quite well, right? Okay. The final question, will Silicon Valley still be relevant? This was also a question, I think, from EE Times recently. Yeah. Will Silicon Valley still be a relevant player in this industry? Being there for more than 25 years, I have watched that Silicon Valley is definitely characterized by its creativity and innovation. After I went back to Taiwan, right, I noticed a clear difference in culture. The Taiwan culture or the Oriental culture, I think in Korean is pretty much the same. It emphasized the discipline a lot. So if you ask an engineer to jump, they will ask you how high. And once you tell him the target, he will continue to try until he meets the target. In the Silicon Valley, sometimes it's difficult to manage an engineer because they don't necessarily are so disciplined, but they create. They emphasize creativity a lot. And that is embedded in the culture. And Google, I think they will continue to innovate. They will outsource. They will go to offshore for areas that cost-wise is too high. And that has been the case since the beginning of the semiconductor industry, starting from assembly and the test, and now foundry and design, right? They will continue to do that. But it's embedded in the Silicon Valley culture or in the US culture, they will continue to innovate. So that ends my part of the presentation. Thank you so much